All right, so this is going to be a video about finding the average value of a function. To introduce this video, basically what we're trying to look for basically is, say you have some function f like I have right here in red. Imagine all these y values. So there's a y value in every single one of these infinitely many points between a and b. So you have to imagine all of these y values. There's all these different y values. Some are higher than others, some are lower, and so on. You can kind of just imagine all these y values. What if you took all of those y values and you tried to find the average of them? What would it be? So that's essentially what we're trying to figure out. What was the average value of a function? To teach this concept, to actually teach where the equation comes from for this average value, I'm going to use a very basic concrete example of average height of people, and then we're going to kind of transform that into a more abstract actual function to try to figure out how to find this average value of all of these y's that are along this graph on this interval from a to b. So here we go. To teach this, I'm going to be using a fairly straightforward example of just the average height of people. Now, the average value of the function, it's basically the average f value, or the average y value, I should say, for every single point that's on a certain interval for a function. So that's what we're essentially going to be looking for. It'll make more sense when I actually show you a graph, but for now, I'm going to try to use this average height of 4 people as a way of teaching how to find the average value of a y value. Okay, so if you notice, I have 4 different size stick figures here, and I'm going to say, what is the average height? And one way of doing it is if you said the sum of the heights divided by 4 is going to be equal to, so I'm going to write that in here, is equal to the average height. Average height. Okay, so that means that this average height right here is some height that if we took a person that was the same height as that average height and put them and line them up with these 4 people, it should be more or less about even between all of them. So to kind of show this, I'm going to take this line right here, so this yellow line. And what I'm going to do is I'm just going to move it up. So you can imagine this yellow line represents the average height. Obviously, the average height isn't going to be down here because every single person is taller than this. The average height won't be here either because the smallest person has this height. The average, even though this is going to throw off the average, it'll make it a little bit lower. We still have these taller people, so it's going to bring the average up. And essentially what you're doing, this middle point right here, is going to be equal to the heights that are above this line are equal to the heights that are below it. So it's probably... and this is just a straight eyeball, and this isn't going to be very exact, but probably somewhere like right here. Okay, so you can kind of see the height between this bar and this shortest person right here is going to be equal to the height of from this line to this person, top of this person's head, from the line to this person's head. So it's kind of about the same. This person's probably about the average of these 4. So just kind of give an idea. This represents this average height. So I'm going to write that in here. This line represents the average height right here. Okay, all right, so from here what I'm going to do is I am going to multiply both sides by 4 here. Now what this 4 represents is how many people there are, but if in a way, what you can think about this 4 representing is the width across from all of these people. So there's 1, 2, 3, 4. And what I'm going to do is I'm going to draw that in, basically going to be the base right here. We can just say that this base has a distance of 4 here. And essentially what we did is we ended up making a rectangle. So I'm going to actually make the rectangle right here with that yellow line right here. Okay. An interesting thing about the area of this rectangle is that it's going to be 4 times the average height of those 4 people. And that was actually going to represent the area of that rectangle that I just drew in. Now the average height is right here, so what I'm going to do, and I said it was 4 times the average height, I'm just going to multiply this 4 over here, and you end up with the sum of their heights, so I'm going to write that down right here, the sum of their heights is equal to 4 times the average height. So now if you think about it, this 4 times the average height, again it's going 4 across, and then the average height is this up and down here, is basically the area. It's basically this area right here of this rectangle. So this part right here is going to be represented by that 4 times the average height. Okay, so if you add up all these heights, it's going to equal to the area of all of this right here. So essentially what we're going to be doing is we're going to be using this fact that the sum of all their heights of all of these people is equal to the area of this rectangle here. So as long as you understand that, you should understand the next part where we're going to get a little bit more abstract with an actual graph. So here we go. Okay, so that concrete example I just showed, we're going to try to apply the understanding and the concepts from that previous example to more of an abstract graph that we have here. So essentially we're going to try to find the average value of this y, these y values in this function f right here. So to kind of draw the parallel with the stick figures, you can kind of imagine a bunch of stick figures lined up right here, but they're infinitely thin stick figures. So you can kind of imagine, I'm going to kind of spread this out because it's going to take me forever to draw infinitely many of them. Just imagine a bunch of them all right here. We're trying to find the average height of every single one of these lines right here. Okay, so act like they're just people and we're trying to find the average heights just like before. Okay, so what I'm going to do just like before is I'm going to move this green line. This green line is going to represent the average y value in this case. And again, this y value is always based on the height of all these lines here. So I'm going to move this somewhere where it seems like the height above the line is equal to the height below the line. Okay, or I'm sorry, the difference between the heights. So like, for example, this blue right here is above the green line, and then this white part right here is a bunch of spots where it's below it. This looks pretty good right here. One way you can kind of tell, because we're thinking about infinitely many stick people underneath this rather than 4, we just have infinitely many that are infinitely thin. You can just use the area. So you can imagine it as the area underneath the green. So right here, and then this whole part right here should be equal to this other value, this other area that I'm going to draw in right here. So this area here plus this area here. So basically the purple area should be equal to the pink area. Now that's not exactly 100% exact here because I'm just kind of eyeballing it, but you kind of get the idea. Okay. Another thing that carries over from the previous thing we did is this green line here. You can form a rectangle with it, and the area of this rectangle should be equal to the area underneath that red curve from A to B. So we're going to draw that up really quick. All right, so what I have here, it says the area of this rectangle, so this green rectangle, is equal to, now if you remember from the previous unit, the integral from A to B, so we're going from A to B for this red graph right here. So we're going for the area underneath this red graph right here of f from A to B. So if you remember from our previous example, the area of this rectangle right here is going to be equal to how many people there are times the average height here. So we're going to use this same principle with this abstract example right here. Okay, this is going to be the exact area from A to B, and then it's equal to the area of this rectangle here. Well, the area of the rectangle, so I'm going to kind of start fleshing out this equation a little bit more. So the area of this rectangle is just going to be equal to the width, which is from A to B, or we can just say the base. It's B minus A here. It's just going to be base times height, times this height here. Now, if you remember, this height is supposed to represent the average value of f. So I'm just going to write f, average value here. Okay, the area from A to B of f of x, I'm basically just going to be moving this down here because it doesn't simplify to anything because we're using an abstract example. All right, so then we have something like this. If we, again, this area of this rectangle is the base right here, which is just going to be b minus a. That's going to be the length of that width right here, the base, and then times the height. The height is equal to the average value of f right there is equal to the area completely underneath that red. Okay, now the whole point of this video was to actually find the average value of a function. So essentially all we're trying to do is find this value right here. Well, to find that value, all we need to do is divide both sides by b minus a here, and you end up solving for it. So you end up getting something like this. So that's basically how to find the equation for the average value of a function using integrals and just basically using some really, really simple geometry with this area of a rectangle. So if you have any questions about anything in this video, let me know.